All right, we've already talked about a lot of the stuff that's in topic 1.13, but let's take a quick look at what's going on here. We're talking about the idea of removing a discontinuity or filling the hole. Let's start off with our three conditions. All right, we have talked about three conditions for continuity. You always want to keep those in mind. Number one, if we're talking about a specific place at letter C, f of C has to be defined. The function has to be defined there. All right, these three are very important. Number two, the limit as x approaches C of f of x must exist. All right. And thirdly, the limit as x approaches C of f of x must be the same thing as the function value there. Those three conditions are not going away. These problems are very common on the AP Calculus exam. And if you can remember those three, it will help steer you in the right direction. So if we look at this problem here, they throw this ugly K in it, which always creates a little bit of alarm in people, but it doesn't really need to, because we're told it's known that this limit exists, and we're told that it's continuous. And it's continuous everywhere. All right? And that must mean if it's continuous on negative infinity to infinity, it's also continuous at 4. Right? So that means f of 4 has to be the same thing as the limit value. So what we should do is we should take this piece that we know something about. Let's take the negative 3x plus 18. All right? And let's look at the limit of it, all right, as x approaches 4 from the right, which means let's just plug in 4. Negative 3 times 4 plus 18, and we get 6. All right? So if I plug 4 in to the one that I know enough about, I get 6. Well, for this limit to exist, the left and the right limits need to be the same, so that means this other piece, all right, the x squared minus k must also equal 6 when I plug in 4. So if I put 4 in right here, I get 16 minus k equals 6, which tells me that k's got to be 10. So in other words, when they give you these problems with the letter k in it, there's always one side that I know something about. Plug the number in, all right, and then plug it in to x in the other one and solve for k. It's that simple. All right? That's how, and what we have done on this problem is we have filled the hole. All right? We have removed the discontinuity. Let's look at another problem. Very similar problem. All right, and we can tell by looking at our answers. Remember, there are calculator problems and there are non-calculator problems on the exam. We can tell by looking at our answers that this is a calculator problem. All right? So, let f be the function defined above where k is a constant. For what value of k is f continuous on its domain? Now, this problem looks like it's going against the grain because there's a k in both. All right? But these two, if this is continuous, these two have to be equal to each other. All right? They have to be equal to each other when x is 5. All right? They have to be the same when x is 5. They have to be. All right, so what we do now is just plug in 5 for x. So I'm going to have 12 over k cubed plus 5 equals 25 minus x. I'm sorry, I put the 5 in the wrong place there. When x equals 5, so it's going to be k squared minus 5. All right. And so what do I do here? Well, we're allowed to use graphing calculator, all right? So put this into y1, put this into y2, and find your intersection. All right, that's all we have to do in this problem. So if we go to the graphing calculator, and we plug those two functions in, x squared minus 5 and 12 divided by x cubed plus 5, and I do zoom 6, all right? They are intersecting right here, all right? So I go to second, trace, intersect, move my cursor up to that point, enter, 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 and I get, here we go, the x value is 2.3777, and that was one of our choices. All right, so we will stop there for today.